So the next set of formulas that we're going to be talking about are called half angle formulas. Now let's talk about where half angle formulas came from. So we took our power reduction formulas and we said, okay, if what if we say that 2 theta is actually alpha, then theta is alpha divided by 2, right? Right? So, and that's what we substituted in. But then we do have the squares on the left side. So in order to bring it, again, to reduce the powers, we're going to take the square root on both sides. And that's where these formulas came from. Notice that when we take a square root, we have to account for both the positive and the negative possibility. And it doesn't matter that both, for example, sine of alpha over 2 will be, we're going to have two signs, one positive, one negative. No, that's not what that means. That means that you would have to choose either the positive or the negative sign, depending where your alpha over 2, the quadrant in which alpha over 2 is gonna lie. One more note about half angles formulas. When do we use them? We can use them when our angle is actually half of the standard or well-known angles, like half of 30 degree, for example, is going to be 15. Half of 45 is 22.5. Half of 60, so forth. So half of 60 is 30, actually. That's a well-known angle, but you got what I mean, right? So for example, here we have a sine of 15 degrees, and we can express our sine of 15 in terms of in terms of 30-degree angle. And since 15 degrees is in the first quadrant, we're going to select a positive root of 1 minus cosine of our double angle, right? Of 30 or full angle, divide by 2, right? And plugging in our information that we already know. So we know that cosine 30 degrees is square root of 3 over 2. So we plug it in. Now we need to simplify this expression. I'm gonna turn 1 into 1/2. I mean 2 over 2 minus root of 3 over 2. And instead of drawing a fraction bar to divide by 2, I'm actually gonna write it out. Divided by 2, right? And this whole thing is under the root. Don't forget. So here I'm going to have 2 minus root of 3 over 2. And then remember that to divide by 2 is the same as to multiply by its reciprocal, 1 over 2. We're still under the square root. So what we have is 1 multiplied by 2 minus root of 3. It's just going to be that. And here 2 times 2 is going to be 4. Now I can separate the roots. I can put the numerator under its own root and the denominator under its own root, and simplifying root of 4, I'm going to get the answer of a square root of 2 minus root of 3. Notice that the first root covers everything, including the root of 3. This is still under the root, divided by 2. And that's our answer.